All right, welcome back to the effects. So we're talking about fixed effects, and in the last video I talked about the purpose of fixed effects and what we're trying to do with them, but now we're going to talk about how can we actually estimate a model with fixed effects in it. So the key thing to keep in mind here is that, as I talked about in the last video, we're just controlling for a variable. We've done this before. We've added control variables before. And there's nothing different about just adding a fixed effect, which is a control variable for individual, as opposed to adding any other control variable. I mean, individual is just a categorical control variable, and we talked about how to add those. And so the only real difference is not in the model itself, it's in why we are doing it. It's in the research design. We are adding a control variable not because we want to control for that thing specifically, but because we think that that thing represents a bunch of other individual stuff that we can't measure, and we want to control for that, and so we're controlling for individual, which we think will handle it. There's nothing different here as opposed to just adding a categorical control variable and fixed effects. Mathematically, they are the same thing. It's just why we're doing it is different. So with that in mind, that sort of clears up a lot of difficulties of what's going on with fixed effects. So typically we might set up a model for fixed effects that looks a little bit like this. Just looks like a standard regression model. There are a couple things that are different. Specifically, if you look at those subscripts, we might notice a couple of new subscripts here. So first of all, we have y regressed on x here, but we have y subscript it. What that's saying is that y varies over both individual I and t time. That's indicating that we have panel data. We've measured the same individuals in multiple different time periods. Same thing on the x, and also for the error term. We have it subscripts there telling us that we measure those individual treatments, both for individuals, and that might change over time. We also have the intercept here. Now you'll notice that the beta intercept now has an I subscript of its own. This is telling us that we are allowing each individual I to have their own intercept. That is a typical way that we might write out a fixed effects model, allowing each individual to have their own intercept, which sounds odd. Like, why are we letting them have their own intercept? Didn't I say we were going to add a control variable? Wouldn't that just be adding a different kind of x to it? Well, that is, in effect, what adding an individual control variable means. If we add a categorical control variable and a bunch of binary indicators for that categorical control, what are we actually doing? Well, let's say that we're doing individual countries, for example, and we add Austria as one of the countries. Well, that is a binary variable, 1 if you're Austria, 0 if you're not, which is basically a way of saying, hey, your intercept is changing. Either you're Austria, and we are going to add your coefficient to the intercept, or you're not, and so we won't. So we can envision having all these different categorical controls, these different binary indicators, as just having different intercepts for each individual. Once we have the model set up, we can ask, well, how do we actually estimate that model that we have? And there are two main ways of doing it. One is to just keep on with the very literal thing that I've been talking about of adding a categorical control variable. We could just add a categorical control variable, and that would be one way of estimating fixed effects. This is literally no different at all from just adding a categorical control. You just add it to the regression model and you're done. Now, there is a big downside with this. Typically with a categorical control variable, you're adding 4 different categories, 10 different categories maybe. With fixed effects, you're dealing with controlling for individual, and if you have a lot of data, then you might have thousands or hundreds of thousands of individuals, and you don't really want to try to estimate a regression model with hundreds of thousands of coefficients. It would at the very least be very slow to run. And so while you can just add a categorical control variable to a model as you typically would, it's not generally the best way to do it. Typically, we're going to do what's called the demeaning process, which is a thing that we actually did before when we started introducing control variables in regression. It's just now that this is the more common way of doing it when we talk about fixed effects. And so what is the demeaning approach? Well, it is exactly how it sounds. You take the average of your y variables and all your x variables for each individual, and then you subtract that average out. Again, you will recall this as being the exact same as one of our methods of controlling for variables before in regression. We take what we can predict with our control variables, and then we subtract that prediction out. And when we are controlling for individual, that's what we are doing. How can we predict your outcome variable based on individual? The best prediction that I can really make is to predict the average for that individual for all your different years, or all your different time periods. So if you, on average, exercise 4 times a week across all the different years that I observe you in, well, then my best prediction, just knowing that it's you, is to predict that you're going to exercise 4 hours a week this year. Then I will subtract that prediction out and end up with a demeaned version of your exercise year. So I know that in this year you exercised 1 more year than average. In this year you exercised 1 less year than average. Then I'm going to take that mean and subtract it out, which is going to give me your within variation. I know that in this year you exercised 1 more hour a week than average, and in this year you exercised 1 hour less a week than average. Then I can simply work with those residuals, those demeaned values. I simply regress your demeaned outcome on your demeaned predictors. And that is another way of estimating fixed effects. And this is, in fact, what most software that specifically is designed to estimate fixed effects is actually doing. And that's sort of it. We're just sort of running regression as we normally would, either by literally adding another control variable, as we've been doing a bunch of times, or subtracting out those means, which is one of the first ways that I talked about adding a control variable in the first place, like way back, I think, in chapter 4. The only real adjustment at this point is that it is very common to estimate a fixed effects model using clustered standard errors, where you cluster the standard errors at the level of the fixed effect. This is a very common thing to do. You might expect that the model that you are estimating would have error terms that are more related within individual than they would be between individuals, and so allowing for clusters by individual is one way of allowing that to occur. I won't say that you always have to do this, but it is, I will say, very, very common, and it makes sense why it's very common to do. Now, once we have our fixed effects estimates, how can we interpret them? Conveniently, this is the exact same as interpreting any other regression. It's just that now we have to think in the back of our heads, hey, we're controlling for individual here. So we are focusing on the within variation. So here's a very straightforward fixed effects model where I'm regressing life expectancy on a country's log GDP per capita. I get a coefficient of 9.769, and that is saying that a 1 unit increase in log GDP per capita is associated with a 9.769 unit increase in life expectancy, the exact same as we would interpret any other regression equation, except that it's a 9.769 unit increase within country. So comparing a given country across time, a year in which that country has a 1 unit higher log GDP per capita would be expected to have a 9.769 longer life expectancy in that year compared to the same country in a different year with a lower log GDP per capita. And that's it. It's just a regular regression interpretation, keeping in mind that we are controlling for individual, and so we should have our interpretations within individual, that we are looking at that within variation. Now, I will say one more thing about the estimation of fixed effects models in regression before we go, which is that sometimes you can have more than one set of fixed effects. There's nothing that's stopping you. In fact, it's very common to have what's called a two-way fixed effects model, where you both have a fixed effect for individual and also a fixed effect for the time period, which is intended to allow you to control for sort of shared changes over time. So, for example, if we were using that trade with Germany example, then yeah, maybe different countries are different in terms of just their general characteristics. There's between variation, but also there are just shared changes over time. Maybe in 1 year, Germany's looking really great. Its economy's really popping, so everybody's trading with Germany that year. And so if I add a fixed effect for time as well, that should control for those shared changes across time. Now, I will say it's very common to see these sorts of two-way fixed effects models. They're very easy to do. You just add another fixed effect. It's a little bit harder to do with the demeaning approach, but just have the software do it for you. It's pretty straightforward. But I will say that interpreting these models is a little bit trickier because you have to think, well, I'm looking within individual and also within time, but also those within things interact with each other because, you know, how am I interpreting this? So you can add multiple sets of fixed effects. Just be aware that you're going to be in for a bit of a ride when it comes to interpreting that actual estimate. These models do some weird things that are unexpected sometimes. Read the textbook chapter for a little bit more detail on that. All right, that is it for estimating fixed effects models. Thank you.